This video shows how to solve for the best fit line and best fit curves using the method of group averages. Welcome to Numerical Solutions to CE Problems. The dataset contains 12 data points with even eggs interval. The task is to fit a line and curves using group averages. First is the best fit line, then the best fit quadratic curve which passes to the point with coordinates 2 and 12.68. And last is the best fit exponential curve. With 3 tasks at hand, it would make the computation shorter when we start with an organized table, which would be grouped into 2, wherein the best fit line solution needs the columns and averages of x and y. The quadratic curve solution requires columns for capital X and capital Y. Using the point at 2 and 12.68, capital X is then x plus 2. Capital Y is equated to y minus 12.68 all over x minus 2. The last task, the exponential curve, needs x and capital Y log. So we complete the table starting with the average of x as 1.4. That of y is 10.4433. Now complete the capital X column, giving 2.4, 2.8, 3.2, 3.6, 4, and 4.4. Their average is 3.4. Capital Y is then completed using the formula where the first is 4.375, followed by 3.8583, 3.0375, then 1.775, and 0 instead of the indeterminate solution, and last is 3.375. Take the average of all the capital Y values and get 2.7368. Then for the last column, capital Y is just the logarithm of the original y, which is the small y. So the logarithm of 5.68 is 0.7543. The log of 8.05 is 0.9058. The logarithm of 10.25 is 1.0107. 1.0781 is from 11.97. 1.1031 is the log of 12.68. And the logarithm of 14.03 is 1.1471. Add all these together and take the average, which comes out as 0.9999. Take the second group from x of 2.8 until 4.8. Its average is 3.8. Also place the y counterpart of each x and have their average as 18.9417. Capital X, using the equation of original x plus 2, gives 4.8, 5.2, 5.6, 6, 6.4, and 6.8. The average of these values for capital X is 5.8. For capital Y, there are 3.475, 3.6667, 3.65, 3.59, 3.2958, and 3.3786. Add this all together, then divide the result by 6 to get the average, which is 3.5093. To prepare the computation for the best fit exponential curve, take another column for the logarithm of y, where we get 1.1892 for the log of 2.8, then 1.2325 for the logarithm of 3.2. Next is the logarithm of 3.6 as 1.2676, and 1.2980 for the log of 4. Then the log of 4.4 is 1.3137. Then the logarithm of 4.8 is 1.3452. Add the 6 values and divide the result by 6 again to have 1.2744 as the logarithm of y's average. With the averages of the two groups already completed, we start with the best fit line, where we use the original x and y columns. The first group has an x average of 1.4 and average y of 10.4433. From the second group, the average x is 3.8 and the average y is 18.9417. With the linear equation y is equal to ax plus b, we create the two equations from the first group as 10.4433 as equal to 1.4a plus b. And from the second group, we get the second equation as 18.9417 as equal to 3.8a plus b. With the two equations already distinguished, take their difference to solve for the value of a. That is 18.9417 as equal to 3.8a plus b minus the equation of 10.4433 as equal to 1.4a plus b. From the constants, we get 8.4984. Then from 3.8 minus 1.4, we get 2.4a, which gives a as 3.541. This value should be substituted to any of the equations. Say we take equation 1 and have 10.4433 as equal to 1.4 times 3.541 plus b. Transpose terms and get b as 5.4859. Knowing a and b, we can take the best fit line as y as equal to 3.541x plus 5.4859. With the necessary parameters already determined through the tables, we move to looking for the best fit quadratic curve with the format y is equal to ax squared plus b of x plus c. With 3 unknown variables, we are required to create 3 equations. The first 2 equations are taken from the average of the tables, but the third equation will be generated from the point where the curve will be passing, and that is through 2 and 12.68. Plugging this as x and y, the third equation is 12.68 as equal to a times 2 squared plus b times 2 plus c. Now we create the two linear equations using the tables with capital X and Y. The first group shows capital X average as 3.4 and capital Y average is 2.7368. These averages make the first equation as 2.7368 is equal to 3.4a plus b. From the second group, capital X's average is 5.8 and capital Y's average is 3.5093. So the second equation becomes 3.5093 as equal to 5.8a plus b. With the method of elimination, subtract equation 1 from equation 2 and have 3.5093 minus 2.7368, which is 0.7725. Also, 5.8 minus 3.4 gives 2.4 of A. So use these to divide 0.7725 to get A as 0.3219. Use this value into equation 1 and get 2.7368 as equal to 3.4 of 0.3219 plus B. So B is 1.6423. After taking the figures for A and B, we have to look for C using equation 3 and plugging the recently solved values, and that is 12.68 as equal to A times 2 plus B times 2 plus C. Again, A is 0.3219 and B is 1.6423 plugged into the equation, so C solved as 8.1078. Having all three variables identified, we place them in the quadratic equation and get y as 0.3219x squared plus 1.6423x plus 8.1078. Moving on to solve the best fit exponential curve. At this point, we are going to use the columns of the original x and the logarithmic y. From the first group, we have the average of x as 1.4 and the average of logarithmic y as 0.9999. So the first equation is taken as 0.9999 as equal to 1.4a plus b. From the second half, the average x is 3.8 and the average of logarithmic y is 1.2744. So the second equation comes as 1.2744 as equal to 3.8a plus b. Just like what we did with the others, we use method of elimination and subtract equation 1 from equation 2. For the constants, there is 1.2744 less 0.9999 giving 0.2745. And then 3.8 minus 1.4 is 2.4a. Thus, a comes out as 0.1144. And this is considered as the logarithm of lowercase a. So to take the lowercase a, work on exponent, that is e raised to 0.1144, giving smaller case a as 1.1212. If capital A is replaced by 0.1144 in equation 1, b becomes 0.8397. Again, this is the logarithm of lowercase b. So b is then e raised to 0.8397, which is 2.3157. With the exponential equation, we place the variables and come up with y as 1.1212 raised to x times 2.3157.